Okay, let's get started. So do you see all the review questions?
Yeah.
Okay. So I just where like it says like at like this point number 2, lesson summaries, I just opened that up. So if we need to reference something, it's easy.
Okay.
So we'll just start though. What is the name of the important statistical result that guarantees that the sampling distribution of the sample mean will be normal if the sample size is large? So again, like this is the central what is it called? Central limit theorem. So like if it talks about something making something normal or making the distribution normal, it's going to be the central limit theorem. And then question number 2 is the one about the law of large numbers. And the key in that question is it's asking like what makes the sample mean close to the population mean, and that is the law of large numbers.
Are you looking at the textbook thing?
Yeah.
Oh, okay. Review for exam 1. Okay. There's a lot. Is this it? Is this all we're supposed to do today? Or is there a quiz too?
Oh, there is a quiz as well.
Okay.
Yeah.
So I don't think we need to take a long time doing like if like we all know how to find the mean, we all know how to find the standard deviation.
Which
I
of the
guess
following variables is or are categorical?
so. I went and looked at this one at the top, and number 2 is categorical because it doesn't have to do with any numbers.
Yes, I think the same.
Yeah, number 1 is the number of animals, and number 3 is the age, which is a number. So it's talking about color or type.
Okay.
Right.
The mean IQ score in the United States is 100. 20 randomly selected.
Is 112?
Yeah. So the mean is 112. Which two numbers is so which of the numbers is the parameter and which is the statistic?
The parameter is 100, and 112 is the sample stat, right?
Yeah, because the 100 is like the base score. It's what you compare it to. So like you're gonna compare something new with that.
About the population, and the other one is about the sample, right?
Right. So I looked up at the top in lesson 3 recap. It says a parameter is a true but usually unknown number that describes a population, and a statistic is an estimate of a parameter obtained from a sample. So yeah, when you're talking about a sample from a population, it's a statistic versus a parameter.
Right.
So this next one is talking about the type of sampling we can take.
In 5, I choose stratified sample, but I don't know if it's correct or if it is systematic. I'm confused between those.
I chose stratified as well.
Yeah.
Because I think, I'll read the difference between the two. So a systematic sample is every K item in the population beginning at a random starting point. So like so if it's systematic, you say, okay, I'm going to choose a random number, and then every 10 after that, we'll use that one.
Okay. Entonces it is stratified sample.
Yeah, in test it's stratified.
Yeah.
Okay. Andrew, you want to do 6?
Yeah, when designed experiments are conducted in public school systems, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected class. What type of scheme? is implemented, or what sampling scheme is implemented. I don't remember. It's like grouping, something like that.
Scroll up to lesson 2 recap.
Lesson 2 summaries.
Yeah, so go to the lesson summaries and then go to lesson 2 recap.
Okay. This one is cluster.
Yeah.
Yeah.
Because they randomly choose a school and then they
A
get
group.
all the kids from the school.
Mm-hmm.
Yeah.
I'm gonna grab a water bottle real quick.
Okay. Number 7, a school fundraiser. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? I think this
Simple
one's
random sample.
I think
simple
it's
random.
simple random sample.
Yeah. Nice, everybody. Okay, a special interest group is conducting a survey regarding wolves in Yellowstone. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented?
Stratify?
I think it's stratified again.
Some from every group,
So they divide into similar groups.
and then random samples from each group. Yeah.
Yeah, okay, stratified for sure. All right, Daniela, you want to do the next one?
Calculate the descriptive statistics of the amounts spent in crossroads purchase. Give the mean, standard deviation, and 5-number summary of the data. The mean is 4.771,
Yes.
and the standard deviation is 1.912.
Yes.
The minimum is 0.84.
Yep.
The first quartile is 3.42. The median is 5.15.
Uh-huh.
The third quartile is 5.61, and the maximum is 10.45.
Correct. So, Andrew, we got all those by just plugging them into that.
Following the link.
Yeah, following the link and plugging it into that one Excel sheet.
Mm-hmm.
Okay. And also on the exam, I just looked at it. That's part of the materials they give you.
They give
They
you
have
numbers.
they're going to have you use those Excel sheets again, so they give you a new one.
Awesome.
Okay, calculate the descriptive. Oh, you did that, didn't you? Yeah.
And then make the histogram.
Yeah. So I made it. I'll show you. I'll just screen mirror it. 1 second. It's the worst when it does that. Okay, so that's what it looks like.
Okay.
Okay.
Wait. It's not really a histogram. It's kind of a bar graph.
Oh, hold on. How do I change it?
I mean, not to be nitpicky, but
There it is. That's what I wanted.
it doesn't really look like a histogram either.
Dude, I clicked on histogram though.
I know, it should be all the dots. Whatever.
I think it's just showing that it's really right skewed though.
Mm-hmm.
I'm gonna see if I can get it to do the right thing though. No.
No, that's right.
How do you get it to?
See, I was always under the impression that histograms were little dots, but it's just a bar graph.
Right, and you can just draw your line,
And
your
it's
slope.
showing you left and right skewed and stuff like that.
Yeah. Okay.
Okay.
Whatever.
Okay. So with these ones, I was a little bit confused about what the second column is.
The
The squared-
deviation from the mean.
squared- squared deviations.
Uh-huh.
It's the variation, right? The variance.
Oh, okay.
Variance.
It is the variance. Because like the question in 13, it says what quantity is equal to the sum of the numbers in the squared deviations.
It's the variance.
Okay.
Mhm.
And then, I mean, it's pretty easy to get A. It's just, oh man, I wrote down the mean of it all. It was like 38.0 something was the mean.
Mm-hmm.
And so A is just 37.91 minus that.
Mhm.
And
So
then
it's minus 0. Yeah.
and then B is 37.25 minus the mean squared.
Right.
Right. Okay. Sweet. You want to do the next one, Daniela?
Yeah. What is the standard deviation of these temperatures? I got 0.715.
And how did you do that?
I like when the variance
Yeah.
I divided by the number -1, and then I don't know how to say it. Like the square thing, like the
Question.
standard deviation.
Did you take the square root of all the variance?
Yeah.
Okay.
No, the variance, but the variance divided by the number -1 first, and then that number, the like square thing.
Can you write it on a piece of paper and show us?
Yeah, I have it here.
I just don't remember how doing that. Well, I remember doing it, but
Can you see?
yeah.
So this is the variance.
Uh-huh.
I divided by 4. What is the number?
Okay.
-1. And then the result en español is the raíz cuadrada of that. And
Entonces it's underneath the square root.
yeah.
Okay. So the square root is point. Okay, I think I get it. Muchas gracias.
De nada.
You guys, in my shadowing, we made a grilled cheese sandwich with French toast instead of regular bread.
What the heck? What are you shadowing a chef?
Yeah, it was really, really yummy.
That's crazy.
We had a kid with attention deficit disorder, and his weekly goal, at least for this week, was to work on completing a task that had 5 to 7 steps, at least 5 to 7 steps with minimal distraction, and being able to follow vocal cues without excessive prompting.
That's awesome.
So cooking. And they worked on fine motor skills too. Who knew, right? But cooking, you work on a lot of fine motor skills.
That's awesome.
Wow.
So that was one of my hours. So if you want to have a grilled cheese sandwich, I suggest next time you make it French toast first and then grilled cheese.
Okay.
Okay.
Okay. Andrew, give us 15. Can a standard deviation ever be negative?
Yes. True.
No, it cannot.
Yeah, it can go up and down.
No,
a Z score can.
You're a Z score.
but not
It's false,
some.
guys. I was just testing you.
Smart.
Yeah.
Okay, in the same study, the researchers placed thermistors temperature sensors in the 3 seals named Chick, Starburst, and Patty near their spinal cord and brain in the extradural vein. They placed thermistors in 6 other seals named Sir Richard, Jerry, Sammy, Knut, Jonesy, and Butler in their aorta, the largest artery in the body. Finally, there was, oh my gosh, it was just, okay, which location resulted in the most consistent temperature measurements from one seal to another?
extradural
Nice. ¿Por qué?
because the standard deviation is like the
It's small.
short one. The small. So the spread is the last one.
Right. Okay,
Yeah.
Andrew, you got 7. Or Danielle, you want to do 17?
Yeah. In your own words and without using any mathematical symbol or statistical jargon, explain what is the standard deviation is. Do not tell how to calculate the standard deviation, but explain what it represents. So, is the measure of the spread
Yes,
in the
period.
distribution.
Yeah, perfect.
So
It's the measure
Danielle,
of the
the
spread.
word is jargon, Jargon,
Jargon.
and it just means like
Jargon?
words that apply to something. So like statistical jargon is words that deal with statistics.
Oh, okay.
Yeah,
Or like
sports jargon that are words like specific to sports.
Or medical jargon is medical terms, medical words.
Okay.
Okay.
Thank you.
So yeah, but you said it perfect. The standard deviation is the spread of samples, how far apart they are from each other.
Mhm.
Awesome. Or I guess from the average. Okay.
68% will be within one standard deviation above and below.
Yes.
And then 95% will be within 2 and 99 within 3.
Cash.
Yeah.
Okay, give the 5-number summary of this data. So the minimum is 2. The first quartile is 4. The average or the mean is 6. The third quartile is 8, and 12 is the maximum. And then there's an outlier at 14.
What's the R stand for?
Where's the R?
Right under the little dot that's out.
Oh, I thought that was a 6.
A 6? Could be a 6.
But I don't know. I think it's an outlier.
I think it's 6.
But what does the 6 mean?
I think it just means that there were 6 over there, but they are out. They're not counted inside of that system because they're outliers.
Okay. The percentage of the data lies between 4 and 8. 68%.
Nice.
Sí.
You know that one. Okay.
Sorry if I stole yours.
No, it was your turn. Estimate the mean of the measured nitrate concentration in Rexburg's drinking water. Holy dump.
I can't do that.
It's not going to happen.
Wait, you can or cannot?
No, I can't do that. I don't know how.
You can, you just don't want to.
No, really, I don't know how.
Okay. Well, let's figure it out. Okay.
Nitrate concentrations above 10 parts per million are considered a health risk for less. Nitrate concentrations in drinking water supply between 1.59 and 2.52 parts per million.
Okay.
1.59 greater than and less than 2.52.
Yeah. We will assume 1.59 is the value of U minus 2 standard deviations and U plus 2 standard deviations is
equal to
2. Okay. It is reasonable to assume the measured nitrate concentration is normally distributed. Use this information to answer. Okay, so
you just got to find the middle of 1.59 and 2.52.
Right, so add them together and then divide it by 2.
So it's 4.11.
1.59 plus 2.52 divided by 2. 2.055. The mean of that is 2.055.
Okay. And then now take 2.055 and subtract 1.59 from it, and then divide that by 2.
Minus 1.59.
And then divide it by 2.
It's 0.2325. That's the standard
That's
deviation?
the standard deviation.
Yeah. Okay, we got it. Let's walk Daniela through that.
We'll assume-
I'm gonna mirror my screen so that I can point to the things we're talking about.
Perfect. I won't
Yeah.
talk.
No, you can talk. Yeah, just
If I talk, it
Okay.
takes it away from you.
yeah, you're right. Unless she like clicks on my screen
Hmm.
and keeps it on.
Uh-huh.
Okay, so what it's saying right here is that in general, the nitrate concentration in Rexburg is between 1.59 and 2.52.
Yeah.
So it's somewhere in between there usually. So then down here we can say we will assume that 1.59 parts per million is the mean of the system minus 2 standard deviations. So it's like if you're looking at the graph, it's like the middle of the graph and you go down to the left 2 standard deviations. And that gives you 1.59.
Uh-huh.
And then if you look at this one, if you start in the middle again at the mean and go up 2 standard deviations, that gives you 2.52.
Uh-huh.
So we found out what the mean is.
What is the number between those ones?
Yeah, so we're trying to find out what this u is. So you just take this number 1.59 and you add 2.52 because those are the two ends of your graph. So you add them together and then you divide it by 2 because there's two numbers you're using.
So it's 2.5.
Yeah,
2.055.
2.05. Yes, that's the mean. So then if you want to find out what the standard deviation is, you just take 2.055 and then you subtract this.
Uh-huh.
And what does that give you?
0.465.
Right. So then that means that's the total. That's 2 standard deviations. So we only want 1. So then you divide that number by 2.
0.232.
0.2325.
Uh-huh.
Yeah, perfect. So now you know the mean, which was 2.055, and you know the standard deviation.
Mm-hmm.
So now we can answer this question.
What to measure nitrate concentration? Between what to measure nitrate concentration do approximately 72% of the values. It's the same?
So remember that the one that we were just looking at is 2 standard deviations away.
Oh.
So we're for the 68%, we only want 1 standard deviation away.
Okay, 1 standard deviation away from what?
From the mean that we found.
Oh. 2.055. It is 2.2875.
Perfect.
So
that's the top.
That's the top part.
And now the bottom is 2.055 minus 1 standard deviation. And that's 1.8225.
1.82.
1.8225.
Yeah.
Mm-hmm. Okay. Okay.
I'm confused about what number 23 is asking.
Yeah, I feel like it's asking what 20 and 21 asked.
What is the mean and standard deviation of the standard normal distribution? It's the same mean.
Yeah, it's got to be the same. Okay. Moving on.
Another people getting
Another
a wrong
longie.
question.
Okay. So the normal distribution is, or the mean is 542.3.
That's the mean, or the mean.
Okay. So what's
And the standard deviation of 120.
I think you are in 24.
Yeah.
I get 1 because it's the same number that the mean, right?
So it's not going to be 100%, is it?
Will be above.
100%.
I think it's 50%.
Right. Because half of the people that take the test are going to score below that too. Right?
Oh, right. Yeah.
Okay. So then what is the probability that a randomly selected student will score below 600? So now we got to
I get.
do some stuff.
Now we take 600 and we subtract 524.3, and then you divide that by the standard deviation.
So that gives us our z-score.
The z-score that I get is 0.4786.
I don't know how you got that.
It's 600 minus 542.
0.3.
0.3 divided by 120.54.
Okay, maybe I got my arithmetic wrong.
I get 0.628.
That's what I have, 0.628. I'll do it again.
So Danielle, I think what you need to do, did you put it all in a calculator?
Yeah, but maybe I wrote.
So what it did was it did the order of operations, and it divided 524 by 120.54, and then it subtracted that from 600.
Oh.
So what you have to do is subtract 524 from 600
first,
and then push equals, and then divide that by 120.54. Does that make sense?
Yep.
Right. I subtract 6. Okay.
So first you have to do the subtraction, and then you divide it by 120.54, or you have to put brackets or parentheses on the numbers.
Yeah.
To group them together.
Then the probability would just be like you take that z-score, you plug it into the applet.
Yeah.
And then you can get the probability.
And then it's everything below.
Yeah. So what was your z-score?
Does this give you into applet?
You'll get it on the test, I saw.
Is there like a link on this review?
On this review, maybe. I don't see one.
I don't have the applet open.
I don't see one. I don't think we need to do it.
That's how you do it.
Yeah. So, but I want to see what the z-score is that Daniela got.
I don't know why, but I get always the z-score 0.478.
Okay, so why don't you do 600 minus, what is it, 542.34?
524. Oh, 542. I did it wrong. I did 524.
542.3. 120.5. Well, we need to apologize because Andrew and I put it in our calculators wrong, and Danielle was doing it right. So lo siento.
No, it's not bien. It's okay.
I'm so sorry.
Okay, so it's everything below that.
Yeah.
That's
and then
so I get
the next one is everything above it.
So
She's like,
It is.
you guys are idiots. I had it right the whole time. And
She's like, I keep doing it right, and it keeps giving me the same answer that you guys didn't get.
So I'm just right all the time, and you guys are always wrong.
Oh no.
Okay, find the GMAT score for the 10th percentile. So you just work it backwards. You put 0.1 into the area and work it backwards.
Mm-hmm. And then the 90th percentile is the same.
It's just going to be, well, it's going to be, no, it's not going to be the z-score, but okay. It's going to be the same distance away.
Mm-hmm.
Find the first quartile. Oh, we got to just do it all. I'll get the applet. Comes up pretty quick on the Google search now. So, okay, so I'm looking for 0.1.
Yeah.
Okay, so, oh wait, no, I'm looking for, is that the 10th percentile? Does that make sense? That the 10th percentile is only 1.2 standard deviations away?
Mm-hmm.
Yeah, I think so.
Okay. So then if this is what I got, or this is what's coming up on the thing.
The 10th percentile is,
See, I put 0.1,
yeah.
and it's giving me a z-score of negative 1.282.
Uh-huh.
So negative 1.282 times the standard deviation, which is 120.54. So negative 1.282 times 120.54. It's negative 154.53228. What's the mean?
The mean
It's
is 154.2.3.
Okay, so
142.3.
okay. Well, Danielle,
it's
what is
not 524.
142.3?
No, I lied. 542.3.
Wait, Daniela, what is it?
542.3.
Okay, 542.3. So then the 10th percentile would have scored 387.76.
Okay.
That makes sense.
Mm-hmm.
Okay, what's the next thing?
The next thing is the 90th percentile.
Okay, so I'm gonna put our stuff over here.
Isn't it everything below that line?
Oh, you're right.
Everything up to it.
Yeah, you're totally right. It's already almost there. Okay, so is that the same z-score? It is. Duh.
It's the same z-score, just on the other end.
Duh. Okay, so that's 1.282 times 120.54. The difference is that this is positive, so when I add to it 542.3, it's going to be 696.8.
That sounds right.
Yeah, okay. Okay, moving on. First quartile is going to be when it's 25.
Yes, I believe so.
I'm going to do like this.
The z-score is negative 0.674.
Yeah. So negative 74 times 120.54. Okay, so that's negative 81 plus 542.3. 461.
461.
Yeah, okay. Is that it? I don't want to do the third quartile. Well, you can do it.
I'll do it.
Okay, you can do it.
0.674 times 120.54 equals, and then plus 542.3, 623.54396.
Awesome.
And then
And the next one is to just you just take the, I was thinking about this because it doesn't give you like a sample mean. It just gives you a sample.
Yeah.
And then it
Mhm.
asks what the mean should be. So I think you just take the population mean and
Yeah,
divide
Yeah.
it by
it should be the same.
the standard deviation divided by the square root of the sample.
Right.
Okay, so that would be
31. Uh,
five
oh,
forty.
the
Yeah,
mean
you walk us through it, Daniela.
the mean is 542.3, and the standard deviation is 31.123.
How did you do that? Did you guys go away?
Hmm?
Oh, how did you do that, Daniela?
Ah, the mean is always the same, and the standard deviation is the standard deviation divided by the square.
Yeah, but this gives you like a super bizarre mean if you do it this way, because usually it's a small difference divided by the standard deviation divided by the square root of whatever the sample number is, the n number. But
Right.
if there isn't like a smaller number up top, then it gives you some bogus z-score or some bogus number.
Right. Like this is giving, so
I got
this is giving me
17.
17.4.
Yeah, and that's not
Is that the new standard deviation?
the standard
What?
deviation gets smaller.
Right. In
When
the
you
right
do-
now the standard deviation is 120.
No, I don't know. It's 100. It's 120.54
Yeah.
But this
divided
gives
by.
what we did gives you a z-score. It doesn't give you a standard deviation.
Oh. Okay. Look.
No, but we're
When
Are
you
you
do the standard deviation by divided by the number, the square root of the n,
yeah.
that gives you a z-score.
Oh. Yeah.
It
No.
doesn't give you a standard deviation and a mean.
No. Yeah. It gives you the standard deviation, right? Because the z-score, you need to divide the mean minus
Yeah,
the.
hold on, Andrew. Andrew, look at my screen. I'm gonna show you where that is. Hold on.
I mean, I understand that the new standard deviation for 542 could be 17. It could only go up that high and down that low.
Right, look. The distribution of sample means is a distribution of all possible sample means for a particular sample size. It has a mean of that and a standard deviation of that.
Yeah.
Yeah, but we did the mean divided by the standard deviation divided by the number.
You're right. So the new standard deviation is 120 divided by.
Yeah, it's not 542
You're right.
divided by those two.
So the new standard deviation is 30.9,
Yes.
and then the mean is still the same.
Yeah, the mean stays the same.
Yeah.
If
Okay.
we wanted a z-score, we would use those.
You're right.
Okay.
But you have to be given a new mean. You have to be given a new average.
Right.
Or like a certain number that you're trying to check.
Yeah.
So what is the standard deviation that you get?
It's like
30
30 something.
30.98.
So Daniela, you take the standard deviation that you have and then you divide that by the square root of n.
Yeah, I did that and I get 31.123.
Yes. 31.123.
Yeah, because I didn't do 0.54. Yep. She's right. She's always right.
Okay. So what's the probability that sample mean GMAT score of SRS number 15 stints will be greater than 600?
So now we use the z-score.
So now we use 600 minus 542.3. divided by the standard deviation, the new standard deviation that we have, right?
Yeah, it's just
Right.
31.123. So that gives us 1.85.
1.85.
Yeah.
Uh-huh.
So now
And
that's the z-score that we have. So now that z-score we put in the applet
the
Where's it supposed to? Is it above or below?
above 600.
Okay.
So it's
I
1.85.
I get 0.968, but I don't know. I am confused when it's below and when it's.
No, so you're supposed to put 1.85 into the z-score for the applet,
Mm-hmm.
Yeah.
and
But
that
when
and then it's everything above that, right?
Yeah.
Yeah. So that gives you 0.0322.
0.0322.
I believe that's correct.
Awesome. Shoot, I guess we should take the quiz fast.
Yeah.
Yep.
Okay. What if it's gonna say, did you do it? Just be done.
What's that?
Wonder if it's gonna like quiz us on stuff. Yep, it's gonna quiz us on stuff.
Ugh.
Holy dump.
Is it long?
31 questions.
What?
No.
Why would they do that?
It's for
I think it's the same. It's exactly the same because the next one, the second one,
oh,
It's-
you're totally right. It's totally the same.
Oh, so it's the thing we just did?
Yeah, did you write everything down, Daniela?
yeah, no, like,
You can say no.
yeah, but what was the
Following
question?
variables is categorical.
Did you write down the things that we talked about?
So the categorical is just the second one, a randomly selected
Yeah,
brand of
right,
toothpaste.
everything.
Okay, so then number 3 is 100 is a parameter, 112 is a statistic.
What?
Sorry, she doesn't know where we are. We're in the quiz.
Right.
The group meeting quiz.
And so we're going through those questions. The first one is true.
Yeah. Is the second is this.
So did you get the second? Did you get the second one?
Yeah. The second one is a randomly selected brand
Yeah.
of toothpaste.
Okay, and then the third one is 100 is the parameter.
But I'm confused because also 112 is a statistic.
Right.
You can
so
select
you
two of
click
them.
both of them.
Both? Oh, yeah.
Okay. And then this one was
Random
stratified,
city.
wasn't it?
Straight. Yeah,
Stratified.
right.
Well, hold on. No, because they're choosing them. Why was this stratified again?
Stratified, I have it, is when the items to be sampled are organized in groups
Okay.
of
Yep.
right?
Perfect. Okay, moving on.
Cluster, right?
Yes.
Oh, yeah.
Random. Simple.
Same.
So a simple random sample was 6. For 7 was stratified.
Right.
Okay, and then 8. Oh, darn it. Did you get the mean? Oh, wait, I still have that.
It's four. I have 4.771.
Yes. Round to 3 decibels, so 4.771. Let me see if it should be 2 at the end. 4.7. Nope, you're good. Okay, and then
Using the silver over the standard deviation of the bond display.
standard deviation was
1.912.
yes. 1.912. Histogram. I created a histogram.
All right.
Well, I think I did.
Yeah, you did.
Yeah.
And you guys saw it.
Mm-hmm.
Okay. What is the value of the number that goes where A is?
I get minus 0.165.
Awesome. What is B?
And V is 0.681.
Okay.
1 0.681.
Perfect.
I think because the next one is 6, the next number, because it's 0.6806, but we need to.
Mm-hmm. Yeah, that's right.
Right. Yeah, 0 rounds to 1 because of the 6.
Yeah.
Yeah. Okay, then 13 is the variance.
Yeah.
Okay, and then 14. What was the standard deviation?
Standard deviation. What is the standard deviation of these temperatures? I get 0.715.
Awesome. Under certain conditions, can the standard deviation be negative, Andrew?
No.
So what was the most consistent of those temperatures?
Extradural.
Uh-huh. What is the third quartile, Andrew?
8.
Mm-hmm. What percentage of the data lies between 4 and 8?
68.
Okay. Wait. 68. Yeah.
Okay. Estimate the
We need to
mean.
put like 68%, right? Okay. Yeah, yeah.
2.055 is 19.
Okay. And 20?
Estimate the standard deviation. We got
Like
0.232 or 0.233.
Right.
Wait, we are in 19, right?
19 was 2.055.
Ah.
And then 20 was 0.233.
Point 233.
Uh-huh. And then what were those between? It was like,
1.823 and 2.288.
yeah. Okay. There's probability that it will score above.
0.5.
Yeah. 0.5. There's probability to score below 600. Did you guys write that down?
No. 600.
The
Hold on. Nope, I didn't. I didn't write it down.
23?
Shoot, 1
It's
second.
going to be a higher percentage than that because 600 is above the mean. Minus 542.3.
I think
That gives you 0.478, and then you put that in the applet.
I have the it's 0.684. I think.
Yes. I just did it, and that's it. 0.684.
Yep.
And what's the probability that I'll score above? It's 1 minus that.
Mm-hmm. 0.316.
Uh-huh. Okay.
0.216.
0.316.
316.
Did you say that?
0.3 or
Yeah.
0.1?
0.316.
Of GMAT response to the 10th percentile.
I didn't wrote that.
So the z-score is negative 1.282 times 120.54 plus 542 point what?
542.3.
So it's 387.76772. So 388.
To the nearest whole number, 388.
388.
Yeah. So then I'll do it again. I'll take it from the other side. And it's
2 times 120.
point. Oh, I just go that way. Okay, 1.282. No, it's the 90th percentile, right?
Yeah, 697. Is that what you get?
Why is it not having me? What did you put into the area?
Into the area?
Yeah.
I just left it at 0.1
Oh, that's what I should have done.
because the other side is 0.9.
You're right. Okay, so it's still one. You're right.
I mean, you can just unclick the other two and click on the right one.
Right. And then what was the mean again? It was 120.54
120.54.
plus 542.3. And you got what, 697?
697.
Okay. Okay.
697, right?
Yeah.
The first quartile of the distribution of GMAT scores.
So it was at 25. And the z-score is negative 674.
Mm-hmm.
0.674 times 120.54 plus 542.3. 461.
Great.
Mm-hmm.
And the third quartile?
So then that would be the positive value.
Would be 0.674 times 120.54 plus 542.3. 624.
Yeah. Okay, what does the mean distribution?
It's the same in, right?
I think so. It says rounded to the nearest tenth, so that's what I would imagine.
So 1.
And the standard deviation we figured was 120.54 divided by the square root.
We get 31.123.
Yeah, 31.123. And then 31, what's the probability mean? Will be greater than 600.
We get 3.22. Right?
It should be less than that. Because so it's 600 minus 542.3
That's 57.
divided by 120.54 divided by the square root of 15.
And we get a z-score 1.854.
Right, and then you
So
got to
now
do
we got to plug that in the applet.
Yeah.
8. Oh, sorry, I must have misheard you because I heard you say 0.3. It's 0.0319.
0.032.
0.0322.
Is that what you said?
Aha.
I'm sorry.
Yeah. No, it's okay.
Okay, I'll submit it. Okay. Looking good so far. We missed one.
Which one?
It's the variance. The quantity, it's question 13.
Mm-hmm.
It's not the variance.
What is this? I don't know. What is that? Can it be the mean?
And then it says that our question 18 is wrong as well.
What percentage of data lies between 4 and 8? 2 standard deviations, 68%.
It's not 2, it's 1 standard deviation, so it is
I mean, 1 up
68.
and 1 down.
Right. But it is 68%, but why did we get it wrong?
If the answer is 66%, then input only 66, not 0.66.
Right.
That should be right. 60, is it 69?
Maybe because it needs to be rounded. I'll put it in the applet and see.
It might be 68 point something.
Yeah, it's 68.27.
Which is still 68.
Yeah.
We need to put 68.7.
0.27.
Point what?
68.27.
27. Okay, thank you. And
Well, if that stays wrong, I'm just going to leave it wrong.
Yeah, I'm okay with what we got. But I think that question 13 is none of these are correct.
I have that the variance is the square of the standard deviation.
Yeah, but so the question 13 asks for the sum of the numbers.
All of the numbers added up.
So it's that far right column just added together.
I think the answer need to be in lesson 3, but I don't know.
I'm okay with what I got though. So
Yeah, I just submitted. So
did you do none of these is correct though?
Yeah.
Okay. See if that's right.
And it's being weird. And yep, I'm sure I want to submit. They asked me like 4 times. You want to submit? Are you sure you want to submit? Are you really sure you want to submit?
Maybe you're not sure.
So we are gonna submit, right?
Yes.
Yes. And it's loading, it's loading, it's loading, it's loading. Submitted. What does this say? 96.7%.
So did you get question 13 right?
Let's see here. 13 is correct, yes.
Okay, so what?
18
So,
is still marked wrong.
so I think Danielle, I think you were right that the variance is the square of all of the sum of all of those.
Okay.
Okay, I have to go, so I'm gonna stop recording and send you on your way.
Sounds good.
Okay.
Okay, bye.